So this talk is going to be a little bit different than some of the other ones you've heard today. We're going to go kind of more of a developer-centric approach to talk about what happens when you start, say, more than one Kubernetes cluster, and how do you access applications that are not in the same cluster that your application is in. I'm Nick Nellis. I'm a field engineer at Solo. I've worked a lot on Istio in the last 4 or 5 years, mainly from an end user. I was one of the first end users to get Istio to production. And so now I help a lot of customers like yourself implementing Istio in lots of technical and hard environments. So if you have any hard problems, bring them over my way. I enjoy those. What I found interesting, I found a really neat infographic here, is that, actually, before I even said that, how many people are running more than one Kubernetes cluster in production? Most of you. So this survey, which actually is really interesting from the CNCF, is that people running just one cluster in production is actually decreasing, and multiple clusters in production is rapidly increasing from 6 to 10 to 50 plus. And so we're going to kind of talk about the evolution of that as it relates to service mesh today. Kind of some of the reasons why that is because using Kubernetes is so much easier than it has been in the past. Managed services are rapidly on the rise, and due to that, people are being more enabled to deploy Kubernetes clusters for any type of use case, whether that be per team or per product or for a lot of different reasons. And so with these Kubernetes clusters that are getting deployed, we got to talk about how service mesh fits into this ecosystem that's kind of changing. And so today we're going to talk about a little bit of a service mesh journey, and specifically we're going to talk about a little bit about the operations and the developers who use that service mesh in a multi-cluster environment. And then we're going to talk a little bit at the end, a little bit about how Gloo Mesh makes that easy. So in a single cluster service mesh, something like Istio, it's really easy. You get all of the features of Istio out of the box. You get secure communication, observability, you get monitoring, and this is all managed by that Istio control plane. There's a lot of really great features, just kind of built out of the box. You deploy Istio, you get all these features relatively easily. You also get to keep some of your DNS naming, so you get to use kubedns. So if the front end here needs to talk to the back end service, it's just using the same call that it was before, but now there's a sidecar attached to it. And so it's kind of a seamless place, and obviously ambient mesh makes that a lot easier. But what happens if we add a gateway? So now you want your traffic, you want to expose your backend through an ingress gateway and internally. And what that does is typically companies stand up 2 different DNS names. You have 2 different ways to access your backend application. And now it's kind of confusing. Your application has to be more environment aware of where it is and how it accesses that application. And this is kind of a logical step for probably most of you who started with Kubernetes, is now you have to manage 2 different host names. Because if you were to share, say, that new backend my.mycompany.internal, you'd be hairpinning. Your front-end application would leave your cluster, enter through the gateway to talk to the backend, and that's not very efficient. So next thing we want to talk about, well, what happens if the backend application, which was owned by Team B, moves to another cluster? And then we're going to talk about how routing has changed due to this. If you were implementing a service mesh, and probably if you've done this before, the first kind of logical step is just redeploying everything somewhere else. And so that means 2 Istios, maybe 2 monitoring stacks like Prometheus and Grafana, 2 Kialis. And we see this a lot with our customers, that they'll just deploy Kiali in every cluster, and now you have to know which cluster it's running in so you can go do the local cluster observability. And so as this grows, your problems grow too. And then there's no easy way for front end now to reach back end. Now it has to leave your cluster and probably enter through an ingress gateway. So it's pretty much 2 times the work at this point. But specifically, we're going to focus on some of the routing. So how does the front end reach the back end? It can no longer use that DNS host name that it was using before. And so by one team moving their application, you now have to update your own application. And as you grow, and this problem becomes a lot harder at scale. To do this today, now you're going to have to change your front-end application to call a load balancer, which then goes through an ingress gateway and then to the back-end application. But this problem actually gets a little bit harder. What if I have two of them? Well, your front-end application can still call that same host name, but now if you had, let's say Team B decided to make their application highly available. So they deployed one in US East and then in US West. The front-end application actually has no say on where that request is going. And so now you're going to get even more you get routing that's just not efficient, essentially. So without service mesh, this problem actually exists in Shipped. We're giving a talk tomorrow at Service Mesh Con about this specific problem that they had in their environment. And they came up with a really crazy, unique solution to do this without service mesh. So all of their internal applications have a unique DNS hostname, and that actually their applications, all calls leave the cluster for essentially a global gateway, and then that gateway is told where the next route needs to happen. But if you notice here, there's like 4 or 5 hops depending on the route you were taking. And so it's very inefficient, but what it allowed them to do is actually migrate cloud providers. And so they sacrificed a ton of efficiency for high availability and then migration. But you don't have to settle with this. Something like Gloo Mesh can actually be placed on top of this to significantly improve the routing between those clusters. And what it does is it lets Istio do what it's best at, and that's managing a single cluster. And so each Istio cluster is going to be singly managed, but then over the top of it, we put Gloo Mesh, and it stitches those together into a thing we call a virtual mesh. And so what that does is it essentially takes those service mesh features that I talked about in a single cluster and moves them to be environment-wide for every cluster. That means secure communication even when you leave your cluster, a single global control plane where you manage all of your fleet of service meshes as one. Intelligent routing, and we're going to talk a little bit about the intelligent routing, how we can improve that shipped architecture so that even though they still have that kind of setup today, we can be much smarter about how we do our routing. And then observability. So now we have that single pane of glass where all those service meshes can feed their observability information and you can view it from one spot. So from kind of an architecture diagram, this is what it looks like. You have your single Istio D deployments. And today we support both open source and a customized version that has some added features into it that we offer. And then when you just attach a management plane on top of that, which we call Gloo Mesh, or Gloo Platform now, excuse me. And then that tells each Istio exactly what it needs to know to solve the routing problems of that cluster. And so it's essentially environment aware and it's contextual. So it knows where all your other applications are and how to best route to those. And it can also support kind of best routing cases if locality is a factor. One really unique feature about what Gloo Mesh offers is the idea of global host names. So kind of along the same stuff that Shane was talking about in terms of Spire, you can give all of your applications a unique identity, but now with Gloo Mesh, you can also give them a unique host name. And so this host name essentially is available to any cluster running Gloo Mesh, and then it makes your application available from any other cluster. We have all kinds of security and stuff built in as well, so that if you don't want somebody to access your service, they can't. But now you can essentially make your service unique to your entire environment. And then a developer doesn't necessarily need to know where that application lives, because between Gloo Mesh and Istio, we're going to figure out how to route it there securely and efficiently. And what's really unique about this is that it allows for dynamic updates. So let's say your backend application, they decide again they want to move that backend application to a different cluster. Well, because Gloo Mesh kind of sits on top of that, it can identify that it's been moved and update all the routing in real time. And so now, regardless of where your application is running, that front end doesn't have to change, and it'll automatically and dynamically update to a best path routing. And what's really great about something like in the shipped environment is in this multi-cloud kind of hybrid environment, even if you move clouds, this host name will still be retained within the virtual mesh, and the routing will just be updated accordingly. So it's a lot more, allows for a lot more seamless migrations. We have some customers that are migrating from on-prem to Kubernetes and public cloud, and the same thing applies. They don't even have to update DNS host names because it just updates with the move of the application. The second thing that we can tie to this DNS is intelligent routing. We can essentially take each route or each different backend application that's running and set a custom priority or even a locality-based priority to it to tell that front-end application where is the best place to route your first request. And then if that one isn't successful, where's the next best place to route it? And this is also updated dynamically, and you can actually change the rules of how you want to determine what priority is. Combining that with the DNS, we are doing a lot of really great route efficiency improvements. And so one really great example of the shipped use case and tying it back is using this host name, we can actually override public DNS names. So if we go back to kind of the shipped use case here, bar.ship.com is going to be our example host name. We can actually hijack that host name in the mesh and then tell the foo application where the best place is to route it. And so we can essentially skip all of the gateway clusters there and have foo route directly to the bar application. And then it saves it. And essentially going from 4 to 5 hops, we can reduce that down to 1 or 2. And then even better for their environment is we can retain the identity of that foo application. So now bar will know exactly where that request came from, and it's over MTLS. And so tying those two together, DNS and then locality-based routing, priority-based routing, it really enhances the service mesh experience, even beyond kind of what Istio does in a single cluster. And I was going to show you a demo here. One demo we have is that with Gloo Mesh, we have a demo that kind of shows the front-end application running in a single cluster, and then one of the features a team decided to implement and put in another cluster. And typically, this would be really hard to orchestrate, but in Gloo Mesh, you can create one custom resource, which would create the global host name and set up all the priority-based load balancing. And then the front-end application could automatically reach this checkout service feature without really having to do much work at all. And Gloo Mesh is really doing the heavy lifting behind the scenes for that one. And so that's my talk about moving from single cluster to multi-cluster Kubernetes and service mesh. Thank you.